Cool. So I'm actually really excited today. I get to talk about one of my favorite things with Python that I think is really not super well known. Has anybody here tried extending GDB with Python before, using the GDB Python extensions? Okay, we have like 2 people. Awesome. So yeah, this is not a super popular thing to do, but I think it's really interesting and really fun to just play with. So this is an advanced talk. Hopefully you already know Python. Hopefully you maybe know GDB even, and might know some of the Python internals. That would help as well. Quick about me, I'm a CPython core developer. I work at Facebook as a production engineer on the Python Foundation team, so you could say I dabble in Python sometimes. And I actually started playing with this as a part of my job. I wanted to be able to access running Python programs and debug them without having to stop. So I started looking into GDB, because that's what GDB is really, really good at. So our high-level goal today, we want to access a running Python process, perform live debugging on that process, and do a little bit extra beyond what GDB can normally do. So a little bit beyond GDB's typical capabilities. Before we get into that though, just in case people don't know a lot about GDB, we'll do a quick GDB primer. And this will just be the building blocks, the most important things you need to know for this talk. We could have a lot of talks, a lot of much longer talks on GDB and all the capabilities it has. So I'm just going to talk about the basics you need to know to understand this talk today. First things first, what is GDB? GDB is probably the most popular Unix debugger of all time, I dare say. It allows you to see what's going on inside a process. So while that process is running, we can use GDB to attach to it, see what's happening inside. If you've ever programmed on Linux using C or C++, you've probably used GDB before. What can it do? Well, if you go to the GDB docs, you will see a lot of things that it can do. To sum it up, though, in one sentence, we can read and write data from the program. So the program that we're attempting to debug, we can read data, we can see what variables are storing, and we can write data. We can send function calls, we can change the what variables store. It's really similar to PDB. So if people are just Python developers and you've used PDB to debug stuff, PDB, you can look inside variables, see what they're doing, you can send code to the process. It's pretty much the same. Out of the box, GDB supports a pretty good number of languages, but it does not by default support Python. You can see it supports C, C++, Go, Rust, assembly, but Python out of the box, I cannot debug a running Python process. And that's pretty much my main goal for today, is debug a Python process. So we'll have to go over how you add the Python extensions to allow GDB to debug Python. Now this is almost so basic, it's hard to explain. GDB commands. If you've used PDB, you've used PDB commands. Commands are the kind of one word, one letter thing you type into the GDB CLI that does stuff. So break will set a breakpoint for us. Next will move us to the next line. If you have no idea what you're doing, help is a GDB command that will tell you all the commands you can use. So this is a GDB command. Just know what that is, understand what that is. The one command I want you to be aware of is the call command, pretty much the same as the print command. We'll go into it in a little bit more detail, but the call command is going to allow us to call code that the debuggee, the program being debugged, will execute itself. So not the GDB process, we can use this to inject code that gets run by the debugged process. Then there's command files. Again, this is actually really simple. A command file is essentially just a script that you take GDB commands that we saw on the last page, write them in a text file. GDB can execute it the same way you would normally execute a script. It just runs all the commands sequentially unless you use flow control. To run a GDB command file, you can source it from within GDB, or you can launch it on the command line with -x. Okay, whew, we're past all the boring stuff. That is GDB, and that's everything you need to know to get this done. Now we're going to talk about extending GDB with Python. So first things first, out of the box, GDB cannot debug Python. That's because it doesn't understand the high-level C Python interpreter information about Python. It can see you have an object and that it's a pointer, but it doesn't know it's a Py object. It doesn't know anything Python-y about that object. So we need to configure GDB with the with Python flag. This gives us Python extensions with GDB, so it's adding a bunch of capabilities to GDB. What it actually does is it embeds a C Python interpreter inside of GDB, which is kind of wild. So don't ask me how it works. GDB now has a C Python interpreter inside of it. Now there's another step that's actually a bit harder. You need to run your process that you want to debug with Python debug symbols. I have done this on CentOS, Ubuntu, and macOS with varying degrees of success and difficulty. This seems like it should be super easy, but sometimes it is. Sometimes it's just download a new debug package or compile Python with debug flag on. Other times you need to move stuff around, add things to GDB init. I will include on the very last slide some documentation that will point you to how to set this up. Hopefully it's easy for you. Sometimes it was for me. But you have to run your debugged program with Python debug symbols in it, so that way GDB has access to the symbol table. So what do we get? Well, we add GDB extensions. Well, we get a few things. First thing, of course, we have access to high-level C Python interpreter information from GDB. So now we no longer just see that that Py object is a generic pointer. We now know it is a Python object. We also get a bunch of new commands that are Python specific, like PyList and PyBT, which I'll show you on the next slide. In addition to that, we can access GDB commands from Python. So GDB gives us this new module. It's like a secret module. You can only find it when you launch GDB. But the GDB module gives you a whole API that lets you do GDB stuff using Python code. And then on top of that, kind of bundled into two, we can subclass the GDB command class and create our own custom GDB commands in Python. So this is how we're going to take what GDB can normally do and make it more. We can extend it using Python because we can build our own custom Python commands. All right, so some of the basic commands that we get, these are now built into Python with GDB. We have PyList. This is just like PDB's list. PyBT, it's like GDB's BT, except it's the backtrace for Python. And then the Python command. This will actually drop us into that C Python interpreter that's embedded into GDB. So let me show you what that looks like. On the left-hand side, I will launch a super simple example process. It's just a loop that prints out its own PID over and over again, so that way we don't have to look for the PID every time. And on the right-hand side, we'll use GDB to attach to that PID, and I'll show you what these commands look like. So PyList, first off, will show us the list, yeah, woo. It shows us the Python code, and it shows us where we are in that Python code, where we're executing. PyBT, we can see the backtrace, so really useful if you're debugging a tricky bug in a C extension maybe. And then Python. So Python drops us into an interpreter. It's not a REPL like you're used to with system Python. It doesn't execute right away. We have to end it, and then GDB will execute all of our code. But this is the C Python interpreter that is embedded into GDB. So pretty neat. Now we're able to run Python code within GDB directly. Then the second thing that the GDB Python extensions gave us was the ability to call GDB commands from Python. And we can do that with the import GDB, the GDB module. Now the GDB module is only available to you in that C Python interpreter in GDB. So if you're on your laptop right now in a Python interpreter trying to import GDB, it will not work. You cannot pip install GDB. This is like a secret module that you can only get to if you pull all the right levers and configure everything correctly and do it all right. You can get the magical GDB module. So just to be super clear, I drew you a diagram. I'm not a designer. So GDB C Python is one thing. in GDB, and then there's the system Python. System Python will not import GDB for you. You have to be within GDB. So, kind of cool. Let's try it. So, we're in GDB. Let's get into our little Python interpreter. And I decided to just print the dir of GDB to show you what all is within this module. As you can imagine, it's a lot of stuff. There are a lot of attributes. There are a bunch of methods. If you know GDB, on Unix systems, it's ptrace essentially under the hood, so you have a lot of low-level kernel stuff. You can select the frame, you can unwind things, you can get the stack, look up symbols. It's all super low level, all really powerful, pretty cool. But programming within that CPython interpreter is not the best experience. I don't want to be typing in that little interpreter and hitting end and having to do that every single time. I want to write stuff in a script and execute things in a script like I normally do as a developer. But it's actually pretty easy to do. So I can create a new file, a new script, do this exact same command, and treat it like a command file. That's another thing that GDB extension gives us, is GDB now understands .py extensions and can find it and execute it the same way you would execute a GDB command file. So all we have to do is pass this command file with -x or with source, and it'll execute the code for us. I didn't show you it again because it looks exactly the same as what you saw on the last screen, but that's how you do it in a command file. So we saw we have a whole bunch of GDB methods available to us, but there's one method to rule them all, and that is GDB Execute. GDB Execute allows us to execute any GDB command as a string form. So if we don't have built into the API some command, we can just pass it into gdb.execute, and GDB will execute it. So for example, we talked before about the call function was going to be important. I can pass into gdb.execute call in quotes, and GDB will execute this function call. So let's take a minute to talk about call. Call is actually a fairly complicated thing that's going on. What it will do is it will look up in the symbol table the function that you've passed in here. So let's say you call function power. It will look up in the symbol table, find function power, find the memory address of pow, and then force the debugged process to jump to that memory address and start running from there. So basically, it pushes to the top of the stack of the debugged process this function that you've passed in. This is also why we need to have symbols loaded. So this is why you need to use the Python debug symbols, because we need symbols available so that call can look up functions and execute them. In the Python debug symbol case, we get debug symbols for the CPython interpreter. So that means I can do CPython code calls here, which might not be something you're super familiar with, because you're a Python developer. You don't know C, you don't necessarily understand the whole back end of Python, but Python has given you a wonderful little tool called the C API. So the C API allows us to make CPython calls fairly simply. And there's a few calls you'll need to know, and it will be all the C code you ever need to know for the rest of your life. First thing, py-run simple string. What this will do, this is C code, it will execute any Python string that you pass into it. So take all those textbooks you bought in college that taught you C, throw them on a bonfire, learn this one C command, and then teach yourself Python, because now you can run CPython code, you can run Python code directly in the CPython interpreter. So this is a pretty powerful command, and this is going to get us really far without knowing C. So we start piecing these things together. We have GDB Execute. GDB Execute can execute call commands. Call can execute C code because we've loaded the symbols for CPython into our GDB process. So put it all together. We call py-run simple string. We can just print a simple hello world, whatever Python string you want, and we put it in gdb.execute. And what this will do is push print hello world onto the top of the stack of our debugged process. So the process that's currently running and we want to debug, this will now say hello world. So let's see how amazingly this works. No worries. This isn't dangerous to do at all. This is totally fine. GDB Execute. You wouldn't believe how many times I had to type this before I got it just right, especially because you have to escape the quotes. Yeah, We can see it going. This is going to be super great. I missed a quote. Oh, that doesn't look good. Oh no, leave GDB. The program we're debugging has seg faulted. GDB gave us a bunch of errors. Oh no! We just willy-nilly did whatever we wanted. We didn't have any safety checks at all. You can't just inject code into a running process. You're a maverick. It's not, what are you doing? So what happened? Ooh, someone might have just said it. So it's something everyone loves to hate, but in our case, it's actually going to work out really well for us. It's a little something called the GIL, the Global Interpreter Lock. The process that we are debugging currently has the lock. We can't just start pushing code. It's going to give us a segmentation fault, as you obviously saw. We need to acquire the GIL. So that way, that process that has it can't do anything for a little bit, but we can do whatever we want. It's actually really easy to acquire the GIL if you know 2 more C commands from the C API. First one, PyGIL state ensure. This gets us the GIL. We take the GIL from the process that's currently holding it. We say, this is now our GIL. We have the lock. You can't do anything. Then, when we're done doing whatever foolery we want, we release the GIL back to the process that's being debugged. So PyGIL release. This is all the C code you need to know. PyRun simple string, PyGIL state ensure, and PyGIL state release. That is it. So let's try that whole rigmarole again. And I think this time I just copied and pasted it because it took like 5 minutes to type that all out. So copy and paste, GDB execute, call PyGIL state ensure, call PyRun simple string with hello world, then release it back, end it, and we can see in the program that has been running and that we're debugging, hello world actually got printed out in the middle of all the stuff it was doing. So we grabbed the GIL, we ran hello world, we released the GIL, it continued on. So we did this all without breaking the program. All right, so little building blocks. We're working our way up to being able to do some more interesting debugging. Next step. That was a lot of code. I copied and pasted it because it took me so long to write into that dinky little interpreter. What I would rather do is have this all in a nice single line command, perhaps, just like those help commands, line break, all that stuff, just one word. We can do that by building our own custom commands. This looks like a lot of code, but it's actually really easy. So we import GDB, then we subclass the GDB command class. You need to initialize it with the name of the command that you want your command to be called. So we did hello_world. So we should be able to, from the GDB CLI, type hello_world. And what it'll do is it calls the invoke function. In our case, we've done the exact same code we just saw. We locked the GIL, we run hello world, we release the GIL. So this is exactly what you just saw. It's now in a repeatable, reusable format as a command called hello command. So do it all over again, launch our little Python script on the left, and try to debug it on the right. This should look the same as what we just saw, with no segmentation faults. So all I have to do now is type hello world, the command that I just registered to GDB. So I registered it. I passed in the command file with the -x. So GDB loaded our command file up. Everything that was within there is now within GDB. It understands it. And I can just run hello world, and it pushes that onto the stack of my debugged program. Pretty cool. That leads us to what our final solution is. We've got all of our pieces. We can build them up and together into one workable script that can do something pretty neat. So in our case, we want to debug memory usage in a running Python process without hurting the process, without killing the process. First step is to write a script that analyzes memory. this is not important to this talk. So I pretty much just took a third-party library called Pimpler that already does a bunch of memory analysis for us and printed out a summary. You can see I did this in a whole different file. You can have a whole program written in separate files, doing a lot of complicated stuff, whatever you want. In this case, it's just a simple couple lines to print out the memory of our program. The second step, and you've already seen this, is we want to acquire the GIL. In this case, we wanted to make the GIL a decorator. So that way, for any new command we want to write, we don't have to keep writing those same 2 lines over and over again around all the code. So we just write it as a reusable decorator. Then we create a new, slightly more complicated custom GDB command, but it's still using the same essential stuff. We still use GDB Execute. We call pyrun simple string. The only thing we do different is now we open the file that we've written and execute it. I'm not saying this is the safest thing to do in the world, but it's very effective for this presentation. So we can open the file name, execute it with pyrun simple string, and we will get all of that memory analysis that we wrote in another file pushed to our debugged code. Last step within the GDB commands file is we need to execute that command. So we can execute any command we want. Since we've registered this command as file_command, it's fairly easy to just call file command and then pass in an argument, in this case, the file name. And last thing, we don't want to be running GDB-X on the command line over and over again. We want this to all be in a nice Python script. So we make a main script with a main class and put a subprocess in it that will do the launching of GDB for us. And you can see that we pass in with -x the GDB commands file that we were just working on for the last few slides. And that's it. So let's run it and see what it looks like. Same super simple example. It actually doesn't have very much interesting going on in its memory, but that's OK. And then instead of GDBing, hopefully the curtain's not blocking it, but you can do sudo python3 main.py, pass in the PID, and boom, we get this nice table in the debugged process telling us the memory of the debugged process. So we can see all the objects, all of their size, what their types are of the debugged process using GDB, and then the process continues on. So we didn't kill it, we didn't affect it for very long. You do affect it for a period of time, but hopefully not an aggressively large period of time. And that's it. So, thanks. Cool. So if you guys want to see the full code a little bit more fleshed out, I know you just saw like a bunch of pieces on slides. I recently open sourced the memory analyzer tool, which is this a bit bigger. It's in the Facebook Incubator GitHub, so please go check it out and make pull requests if you're interested. Then there's the GDB documentation and Python GDB documentation. So here you can find all the information about the GDB API, how to set up GDB, how to set up Python with the correct debug symbols, all that jazz. So please go ahead and check that out if you have questions around that. And now that's actually it.
Okay, so I just want to recap exactly what happened in the very beginning.
OK.
Okay, so just from the part that I totally understood, so you start GDB, right?
Yes.
And you attach it to a process.
Yes.
And then you start a CPython interpreter within GDB.
Well, it's built into GDB. So if just in the beginning, when you saw me type Python and it dropped into a little interpreter, then yeah, that's like going into the CPython interpreter. It's technically already all built into GDB for you. So when we pass a GDB command file or a Python script to it, it accesses the CPython stuff that it knows about inside of itself to run that.
Wow, okay. The last thing that I noticed that I actually saw happen was that then you use the Python C interpreter to tell GDB to add a function call to the top of the stack of the process that GDB is attached to.
Yes.
And then the process runs that function call.
Yes. The call command is like very complicated and magical. I spent a while understanding what it does, but at like the top highest level, that's how it works. Yes.
Okay, thank you.
Okay, cool. Yeah.
I was wondering, if you don't use PDB anymore, and I mean, was it why did you go this route instead of trying to extend PDB to make it? I always dreamed of PDB being attachable to a running process like GDB. But I guess if you went this route, there's a good reason, right? That it's not feasible or.
I think that I don't think that out of the box PDB can attach to a running process, at least not that I'm aware of. So GDB seemed like the simplest solution in order to attach to a running process. I think if I had wanted to use ptrace or something like that, it maybe could have been a bit more powerful because it would be accessing ptrace directly instead of through GDB. But GDB gives you the extra benefit of being compatible with Mac OS and Windows as well as Linux. But yeah, I basically picked GDB instead of PDB because I don't think PDB can inject into a running process the same way.
Thanks.
Mm-hmm.
Hi.
Yeah.
I'm curious, can you debug other languages with Python using this method, or?
You should be able to create GDB extensions like GDB commands and stuff like that in Python and have it work on other languages. I think it should work. I don't see why not. It's just like analyzing Python, you need the extra CPython symbols loaded in order to see Python, but I don't see why you couldn't do some Python code. It would depend, I guess, on what you're trying to do. But there's no reason it couldn't run. It maybe just the Python code would fail, but I think it's worth a try. I don't know. I've never tried it.
Huh?
Yeah.
Thank you for the talk. I thought it was a lot of fun.
Cool.
I have one question, which is, have you explored making a REPL for this? So I can, instead of writing a script, just write Python commands and then see the impact of that on my process. I don't quite like writing GDB commands, and so the fact that I can write Python would be a lot more fun. So I think a REPL for doing this might be something really cool for it to interface with my existing Python processes.
Yeah, I haven't thought about it, no, but it would be pretty interesting. I don't think it'd be terribly hard to do. Just need some of the fundamentals built into it. So yeah, that could be fun.
Yeah, I think your talk had a great foundation for that, especially with like the decorators and some of the
Cool.
stuff you were doing.
Awesome. Thank you.
Hi, Lisa.
Hi.
My name is Paul.
Hi, Paul.
I'm curious if the implementation is similar in Python 2.
So yes, it is similar with Python 2. If you want to configure GDB with Python, you can select which version of Python you want it configured for. So GDB extensions work for Python 2. As far as I am aware, you have to pick either or, like GDB, either Python 2 or Python 3. But in terms of subclassing the commands and stuff, the only thing that would be different on my slides would probably be the F strings. Otherwise, it's pretty much the same.
Okay. All right. Thank you.
Yeah.
Hi, on one of the early slides, there was a /configure --with -python, and I didn't see
Yes.
that in the demo. Where does that fit in?
Sorry, so that's configuring GDB. So if you download GDB from source and you want to build it yourself, you can configure it with Python, with Python flag. I have seen some distros where you're able to install GDB with Python already turned on for you, but it's totally depends on like what system you're on. So if you download GDB from source, you can configure it yourself with Python flags.
Okay, one more question. So is there anything special that needs to be taken account if you debug something that like is using a C extension in Python, let's say a NumPy or more complicated library? So
Anything special that needs to be taken into account?
I guess let's say if the C extension, if it releases the GIL, I guess then you can just grab it and it should be fine.
Yeah, that could happen where the C extension is doing funky stuff with the GIL. I haven't attempted to play with it too much, but it might be interesting. You might want to try to acquire the GIL only at certain points, only at certain specific points instead of just acquiring it like whenever. The way I'm doing it is kind of sloppy here, where you just run the code whenever you execute GDB and it starts right away. You could definitely be a little bit smarter about it and figuring out where you are within the code before you start executing this. That would probably be significantly safer.
Yeah.
And for C extensions, yeah, that would make a lot more sense.
Yeah, I wonder, like, let's say you have a network intensive, like a piece of Python code and like it's
Yeah.
executing somewhere in the lower levels. I mean, is it safe?
I mean, it's not the safest thing. It could go bad.
Okay, thank you.
All right. right, cool. Well, I'll hang out for a little bit if anyone has any more questions. I just think this is really fun to like nerd out about, so happy to chat. Bravo. Thank you.